So this video is going to be about chain rule. Now, chain rule is this very interesting and very important concept in differentiation, and I'm gonna attempt to explain it. It's pretty simple, so just bear with me. I'll try to do my best and help you understand it. Now, the first time I learned differentiation, I did have a problem with it, and I hope I can clear the same doubts. Okay, now let's say we have something like some differential like this: du by dv. Now, how do we do that? I mean, okay, of course we don't have the functions yet, but if you have something, let's say u is a function of x, function function of x, and v is a different variable, right? So how can we differentiate u in a way that we can get the final answer in terms of x? Now, what we can do is we can multiply the differential term. So we have du divided by dv, and we can do this times dx divided by dx, which can also be written as du divided by dx times dx divided by dv. Now, see what I've done over here. I have u over here, and because I know that u is a function of x, I can put the differential term of like the dx over here times dx divided by dv. So if it's possible to calculate this, and we obviously know that it's possible to calculate this, we can get a, a correct answer. So well, that's the gist of it. It's better to actually use examples to show it. I'll show some examples now. And not these examples, these are some problems, but let me just try to explain it with some examples. Now, I'm going to ask you one thing. Remember the time when I think the first video or the second video which has some formulae on differentiation. So in that second video, I have explained some common formulae, which say stuff like d by dx of sine x gives cos of x. Now, if you have noticed, all of these had dx in over here. So basically it was with respect to x. But what if we have something like this? What is d by dx of sine of cos x? How do we do that? Now, just take a look at this. Here we have cos x, and here we have x. So we cannot apply the same rule over here. We have to use something known as chain rule. And essentially what we can do is we can take it like this. So we can take it like d by dx times sine of cos x times d of cos x divided by d of cos x. Why are we doing that? Well, take a look at this. When we have x over here, we have x over here, and then that's the time when we can use this formula and we can get cos x. So if we have cos x over here, we need to have cos x over here too, so that we can use that formula and calculate that. So basically what we can do is we can interchange these places, and when we interchange these places, what we get is d of sine of cos x divided by d of cos x times d of cos x divided by d of x. Just look at how simple it has become, because now what we can do is we can utilize this, and we can use this rule to find the derivative of this term, and we can use our simple laws I discussed in the second video, the formula, to calculate this. So basically we already have the answer. We have cos of cos x, because if you notice, this is cos of x because this is x, and this should be cos of cos x because that's the angle over here, times minus sine of x, which is the value for this. So this points to this and this points to this, and there we have it. We have an answer. So that's how we use well, chain rule, and it simplifies things very much. And now let me just solve some few more questions, or let's just start off with the problems so that we can clear things up and you understand this finally. Alright, so let's use green. Green is a nice color. Alright, so the first one is, the question is, let's try the question, Q&A. So the question is, y is equal to 3x plus 1 whole square. Alright, this is a very interesting problem. Well, we can do this in a lot of ways. We can use, we can take it as 3x plus 1 times 3x plus 1 and use product rule. We can use it as product rule, prod rule. We can expand it by using a plus b whole square, and we can use power rule. But we can also use chain rule over here. How, you ask? Well, let's see. So we have to find dy by dx is equal to d by dx of 3x plus 1 whole square. Now recall one thing. Recall that we have learned a way of doing this. We have learned the power rule. We learned in the power rule that d of x to the n divided by d of x equal nx to the n minus 1. So because here it was x, here it was x, and here it was x, we could use that and we could use this formula. But we can also use that over here. But the problem here is that we have dx over here and 3x plus 1 over here. So how can we change that? Well, if you guess that we have to multiply with d of 3x plus 1, you're probably right, because that's what we're going to do. We have d of 3x plus 1 whole square divided by d of 3x plus 1 times d of 3x plus 1. So understand that we are essentially multiplying nothing to it. We are multiplying the same terms to both the numerator and the denominator. So we have dx over here because that shifted to this part. This part, and we multiplied these two, this and this. So just look at how simple things have become. Now we can take this, and let's take this as k. If we take this as k, we get something like this: d of k squared divided by d of k, which is the power rule, and we can use the power rule to calculate. That'll be 2k, right? So that's what. So it'll be 2 of 3x plus 1 times d of 3x plus 1. What is that? And that should be 3, because that's the rule. Well, and because we know that's a different, the derivative of the constant is 0, this should be 6 times 3x plus 1, which is equal to 18x plus 6. But that is the final answer. How cool is that? Let's try to do another one. Just rub this. So I hope you understand what I meant by what I actually wrote in that explanation. We had du divided by dv, and we could multiply it by dx in both the directions. Both the numerator and the denominator, and we get du by dx times dx by dv, and we get the answer with that. And well, let's solve another problem. Here, the problem is y is equal to root of 13x square minus 5x plus 8, which can also be written as 13x square minus 5x plus 8 to the 1 by square root, 1 by 2. So how do we find dy by dx over here? Now, we have to use chain rule over here, and this is a very interesting problem, and I'll just tell you why in a second. So we have 13x square minus 5x plus 8 to the 1 by 2. Now notice over here is the same thing. When we use power rule, we had d of x to the some value, let's say k, divided by dx is equal to k times x to the k minus 1. Notice over here that we had x over here and we had x over here. Let me try to say that. Say that again. That's x over here and x over here. We could use that over here if we have d of 13x square minus 5x plus 8, because we need something which is common. We have x, we need this term, and we need this same term somewhere over here to apply power rule. So how can we do that? Well, we can multiply, right? So we can multiply this with d of 13x square minus 5x plus 8 divided by d of 13x square minus 5x plus 8. How awesome is that? Now, when we do that, what we get is, now we can interchange the positions. We can put this over here and we can put this over here. Essentially, we have something like 1 by 2 of 13x square. Notice I'm skipping some steps over here. I'm directly using the power rule. That's 1 by 2 minus 1 times d by dx, and this dx is the same dx of 13x square minus 5x plus 8. Let's use another ink color. So we have 1 by 2 root this because this equals minus 1 by 2, 13x square minus 5x plus 8 times, well, let's just write it over here, right? So that'll be 26x minus 5. And well, this should be the final answer. I hope you're getting this. Let's do another problem and let's try to understand well, finally what the chain rule actually tells us. Let's just rub this. Careful, Job. I have not touched the yellow line. It's like that game. Alright, so we have rubbed it. Oh, okay. Lovely. So we have the next question. We have y is equal to 1 minus 4x plus 7x to the 5th power to the 30th power. Wow, so this looks pretty, it might stymie you because, I mean, it's the 30th power, so how can you find the differential? Well, fear not, because, well, I'm going to have, first of all, yeah, and you could use chain rule, right? Because when we find dy by dx, we are finding this, and well, again with power rule, what happened was we need the same term over here, right? So we have d by d of 1 minus 4x plus 7x to the 5th power to the 30th power divided by d of 1 minus 4x plus 7x to the 5th power times d of 1 minus 4x plus 7x to the 5th power divided by dx. Now, when you cut this, you get 1, right? So we are basically multiplying the same term to the numerator and denominator. And so here, when you use power rule, you get 30 times 1 minus 4x plus 7x to the 5th power, 30 minus 1 times minus 4 plus 35x to the power 4. So we have 35x to the power 4 minus 4 times 30 times 1 minus 4x plus 7x to the 5th to the power 29. And well, this is the final answer. So do you see how easy that was with the help of chain rule? So basically that's what chain rule is. I mean, you should know the preliminary rules basically. If you know those rules, you know what you have to multiply to the numerator and denominator, and on the basis of that you can calculate the final answers like that. So well, I hope you understood this. In the next video, I am going to come up with implicit differentiation and I guess some more concepts of differentiation. So yeah, I hope you liked this video. Please do like, subscribe and comment. See you in the next video. Bye bye.